In this video, you will learn about the 45, 45, 90 special right triangle. The 45, 45, 90 special right triangle has two angles that are 45 degrees each and one angle that is 90 degrees. When solving from leg to hypotenuse, it's getting bigger, so you're going to multiply by 2. When solving the hypotenuse to leg, it's getting smaller, so you're going to divide by root 2. In a 45, 45, 90 special right triangle, we know that two angles are 45 degrees. That means the sides opposite those angles are congruent because it's an isosceles triangle. Therefore, the legs will always be the same length. The hypotenuse is longer, so it's root 2 times as long as the leg. Example number 1. Find the missing side length. I notice that I have both my legs, but I'm missing the hypotenuse. So if you recall, when we go from leg to hypotenuse, it's getting bigger. So all we have to do is multiply by root 2. So I know that my leg is 3. So I'm going to take 3 and multiply it by root 2. That would be my answer for the hypotenuse. However, I want to make sure this is correct, so I'm going to use the Pythagorean Theorem to check. So I have a squared plus b squared equals c squared. So a squared is 3 squared plus b squared, which is 3 squared, and bring down c squared. Now 3 squared is 9 plus 3 squared is 9. Bring down c squared. 9 plus 9 is 18. Bring down c squared. I'm going to take the square root of both sides. Now I'm going to break down 18 to 9 times 2. Bring down c squared. Now I'm going to take the square root of both sides. So I can take out 9, that'll give me 3. And then root 2 will stay inside. And the square root of c squared is just c. So that means my answer does check. The hypotenuse is 3 root 2. Example number 10. Find the missing side lengths. I notice that I have two sides missing, one leg and the hypotenuse. However, I do know what the other leg is, so that means we have two legs that are equal in length because they are congruent. So this leg is 10 units long. Now the hypotenuse, I know that all I have to do is multiply the leg by radical 2. That means my hypotenuse is 10 radical 2. And those are the missing side lengths. Example number 3. Find the missing side lengths. So I notice that I have one missing leg and I have the missing hypotenuse. However, I do know one leg, which is radical 6. That means my other leg is also radical 6 because the legs are congruent. Now, in order to find the hypotenuse, all I have to do is multiply the leg by radical 2. So my leg is radical 6, and I'm going to multiply by radical 2. When I multiply, I end up having radical 12. 6 times 2 gives me 12. However, I cannot leave it that way, so I'm going to break it up. So 4 times 3 will give me 12. And I know that 4 is a perfect square, and that becomes 2, so that will come out of the radical, so it'll be 2 radical 3. So that means the hypotenuse is 2 radical 3. Example number 4. Find the missing side lengths. So I notice that both of my legs are missing, and all I have is my hypotenuse, which is 6. So in order to go from hypotenuse to leg, we need to divide by root 2. So I'm going to take my hypotenuse, which is 6, and divide by root 2. Now we are not allowed to have radicals in the denominator. So in order to get rid of that, I'm going to multiply by root 2 in my numerator and my denominator, which just gives me 1. So 6 times root 2 will give me 6 root 2. And root 2 times root 2 will just give me 2. Because 2 times 2 will give me 4. When I take the square root of 4, that gives me 2. Now I can simplify. 6 divided by 2 will give me 3. So my answer will be 3 root 2. That means both of my legs are 3 root 2. Example number 5. Find the missing side lengths. So I notice that each of my legs are missing, and all I have is my hypotenuse, which is 12. In order to find the legs, we're going from hypotenuse to leg. So that means I'm going to go ahead and divide my hypotenuse by root 2. So I have my hypotenuse, which is 12, divided by root 2. I'm not allowed to have a radical in the denominator. In order to get rid of it, I'm going to multiply my numerator and denominator by root 2. So 12 times root 2 is 12 root 2. And then root 2 times root 2 will give me the square root of 4. The square root of 4 will be 2. I'm going to simplify. 12 divided by 2 will give me 6. That means my answer is 6 root 2. So each of my legs are 6 root 2. Example number 6. Find the missing side lengths. I notice that both of my legs are missing, but I do have my hypotenuse, which is 12 root 6. Now in order to find the legs, we're going from hypotenuse to leg, so we're going to take our hypotenuse and divide by root 2. So my hypotenuse is 12 root 6, and we're going to divide by root 2. Since we can't have a radical in the denominator, we're going to multiply both the numerator and denominator by root 2. So 12 root 6 times root 2 will give me 12, and then 6 times 2 will give me 12. So 12 root 12. And then root 2 times root 2 will give me the square root of 4. The square root of 4 is just 2. Now we're going to simplify. 12 divided by 2 will give me 6. So I have 6 root 12. However, I can break up the 12, so it'll be 6. The square root of 4 times 3 will give me 12. I know that 4 is a perfect square, so the square root of 4 is 2. So I'm going to take the 2 and multiply it with the 6, which gives me 12, and then root 3, because the 3 stays inside. So that means each of my legs are 12 root 3. However, there is a faster way to do this. So I'm going to take my hypotenuse, which is 12 root 6, and we multiply by root 2. Since both the 6 and the 2 are underneath the radical, that means I can divide those. So my answer would be 12, and then 6 divided by 2 will give me 3. So I still get the same answer, which is 12 root 3, just in a faster way. So each of my legs are 12 root 3. Example number 7. A side is 5 units long. What is the length of the diagonal? So they're telling me that the side is 5 units. I notice that this is a square, and a square has equal sides. So that means each of my sides is 5 units long. I also notice that I have 2 triangles, and each of my triangles are isosceles triangles. The reason why I know is because my legs are equal. So that means this is a 45, 45, 90 special right triangle. So that means in order to find the diagonal, which is my hypotenuse, I'm going from leg to hypotenuse. That means I'm going to take my leg and multiply it by root 2. So my leg is 5. I'm going to multiply it by root 2. So that means my diagonal is 5 root 2 units long. Example number 8. The diagonal is 2 root 5. What is the area? So they told me that the diagonal is 2 root 5. And that's also my hypotenuse. So I'm going to go ahead and write it in, 2 root 5. Now in order to find the area of the square, I need to have the side lengths. The side lengths are also the legs to my triangles. So that means we're going to go from hypotenuse to leg. When we go from hypotenuse to leg, we take the hypotenuse, which is 2 root 5, and we divide by root 2. Now I know that I cannot have a square root in my denominator. So that means I'm going to multiply both my numerator and denominator by root 2. So 2 root 5 times root 2 will give me 2 root 10. And root 2 times root 2 will give me the square root of 4. The square root of 4 is 2. Now I'm going to simplify. 2 divided by 2 will give me 1. That means that each of my legs will be root 10 units long. So I'm going to write it in. So I have root 10, root 10, root 10, and root 10. Now in order to find the area of a square, I take the side and I square it. So my side is root 10, and I'm going to square that. So root 10 times root 10 will give me root 100. The square root of 100 is 10. So that means the area of the square is 10 units squared. And that's how you solve for 45, 45, 90 special right triangles.